Afternoon to everyone. Today we will talk about new ventures. I'll define what that is, and then I'm going to talk about the regional geology of the Gippsland Basin. I'll tell you where that is located. It will give you a feel for the type of information that we need when we start to analyze an area. And the Gippsland Basin is the focus for a lot of the exercises that are related to this course. Not just lesson 12 and exercise 12, but a number of them, maybe as many as half of the exercises are using data from Gippsland. So the first slide shows the field's life cycle, and we'll talk about these different steps. But what we need to do is identify opportunities, capture those opportunities, make a discovery of oil or gas, delineate the newly discovered field, install facilities such as an offshore platform, and then produce the hydrocarbons, drain the field, and at some point our ability to drain the field will drop below what is economically reasonable, and we'll abandon the field. So new ventures, that means a geographic area where either the energy industry as a whole or perhaps just our company has not been active, but has some current interest. This might be a totally new basin or sub-basin where no exploration has yet been done. It might be a newly accessible area, some area that in the past our company was not able to be active in. It might be a new play in an old area so that we have production, but maybe now it's from a deeper interval than has ever been tried before. A lot of areas we had conventional production, and then with the explosion of unconventional resources, shale gas, shale oil, tight oil sands, that would be a new play in an old area. So we could say it's an area where our particular company hopes to find large reserves, and that will maintain or expand our future production. And by reserves, I mean volumes of oil or volumes of gas. I've had the privilege to work several new venture areas. I worked up in the Mackenzie Delta area in the deeper water environment than had previously been explored. I was involved when communist China was opened up to Western oil and gas companies. So that was back in 1980. I was involved in some exploration efforts off of Madagascar, which was a new basin back in 2007. And then an ultra-deep water play in the Gulf of Mexico just a couple of years ago. So the work process for geoscience can be broken down into four main stages. And this is what I mentioned on the first slide. First, we have to capture areas of high potential. And by capture, I mean that we obtain the right to do exploration and drill wells, and if we find stuff, develop fields and produce oil and gas. Once we capture an area, hopefully we'll be able to discover hydrocarbon reserves, oil fields or gas fields or combinations of the two. Stage 3 is to initiate production from those newly discovered fields, and then stage 4 would be to deplete the hydrocarbon field. So we can talk about a business cycle. Early in the business cycle is when we're trying to figure out where some new discoveries might be made, and we capture those areas. Slightly further along in time, we make some discoveries, and then further along, we initiate production, whether that's onshore or offshore. And then late in the business cycle is when we're reaching the point where production has declined so much that we're going to abandon the field or maybe sell it to somebody else. So we can talk about some of the changes in the business process as we go from the capture to the discover to the initiate to the deplete the field to abandon or sell. And we can subdivide this into three main focus areas: exploration, the mid stage would be development, and the late stage would be production. So if you work for a very large company like ExxonMobil or Shell, there's an exploration company, there's a development company, there's a production company. If you work for a smaller oil and gas company, then you might have an exploration department, development department, and a production department. As the time in the business cycle goes from early to late, the scale of the analysis also changes. When we're in early exploration, we're trying to capture opportunities. We're doing largely regional studies, maybe some block-wide studies. We get to focus in more on a particular prospect. Then we might focus even more on a particular reservoir. And then we may focus even more on a particular compartment for that particular reservoir. At the bottom, again, we're looking at time in the business cycle, early to late. Above this central line is where the geoscience people, professionals work, and below it in green would be where more of the engineering society professions work. Information and effort increase with geoscience as we go through time. The role of the geoscientists, the number of people with geoscience degrees that are working may start to taper off as we get into the production. We are always increasing our understanding, our information about the geology and the geophysics. Reservoir engineering has only a little bit of a component in the capture and discovery phases. In initiate production, they start to ramp up, and as we get into the production stage, we rely more heavily on engineering than perhaps on the geosciences. So for stage one, capturing opportunities, there's several key questions that we are focused in on. I believe there's over 700 sedimentary basins on our planet, and so which of these 700 have the highest potential for undiscovered hydrocarbons? And even though ExxonMobil and Shell are very large companies, they do not have geoscientists that are working on all 700 sedimentary basins. So it's always a question of high grading where we want to focus our effort and our people. We also want to know which potential areas that we might want to operate in will become available in the near future. So there's no sense in putting a lot of effort studying an area where we don't think we'll be able to operate in the next, say, 10 years. Third question is the landowner, and if it's offshore, for example, it would be the local government, will they have some access available by offering up licenses where we can bid on blocks and get the right to explore and drill wells? And what can we do to get ready to enter some areas that have high potential that are likely to become open to our access in the near future? So as we capture opportunities, typically companies will do regional studies like the coastline off of West Africa. They'll decide where certain focus areas, areas with high potential that maybe haven't been tapped into for one reason or another. The government may offer up some blocks. Here's an example where 8 blocks are up for bids. We would put together play element maps, source, reservoir, trap, seal, and migration, and look for where all 5 of those play elements are favorable. We would find certain geological features, primarily using seismic, to define some leads. So here we have lead A, which straddles block 7 and 8. lead B in Block 8 and lead C in Block 7. We'll do some profit analysis, how profitable might lead A and lead B and lead C be, and then maybe we'll get to the point where our company places bids on both Block 7 and on Block 8. So I talked in lecture 3 about regional studies. I showed this slide. So we do gather as much information on a regional, mega-regional scale, geological maps, consider the plate tectonic setting and plate tectonic history, gravity data, magnetic data, regional seismic lines, what sort of tectonic evolution do we think we've had, what is the main stratigraphic intervals, and which of these might be source rocks and reservoir rocks and sealing rocks. We might be able to put together some paleogeographic maps and whatever else might help us understand the region that we are hoping to gain entrance into. The regional studies gives us the setting of a basin or the sub-basin that we might be interested in bidding on and obtaining permission to explore. And we want to try to understand the characteristics of the region that we are analyzing. We want to turn those characteristics into a set of play element maps. And again, the play elements in my definition would be source, reservoir, trap, seal, and migration. And then play adequacy maps. Is it adequate? Do we have an adequate reservoir? Do we have an adequate seal? We would decide which basins and sub-basins have the highest potential and low risk for discovering and producing oil and gas. And then we want to determine how much to bid for blocks that become open for bid. So as an example of that, we have this fictitious government of the nation of Somalia, and it's announced that the lease sale of 8 blocks will be, the announcement is made on April 1st, and energy companies are invited to submit bids to the government by October 1st. And so that's a 6-month period of time to do the analysis and submit the bids. And that is quite normal these days for governments to have a 6-month period in which to submit the bids. The information that they would get at the time the bids are announced would be the length of the lease, maybe 15 years, maybe 25 years, what sort of monetary and additional commitments would be required to win a block, a lease, how much the government would take. Usually they take a percentage of the production, and then the rest of the production that the company would be able to take, that will be taxed. And then there are typically other terms that have to be weighed into the consideration of whether or not we want to bid and how much we would want to bid. So if you have done exercise 3, this will look familiar. This is an example where 8 blocks are up for bid, and in the exercise I provide you with some maps about reservoir and source and structure, and you put together play element maps, source, reservoir, trap, seal, migration. Look for where these elements are favorably combined. And so you want to identify traps where we have a good quality reservoir, a very effective seal, and a nearby hydrocarbon source or kitchen. And we may also be able to use our seismic to look for some evidence that would verify the presence of hydrocarbons. We talk about direct hydrocarbon indicators, and one of the lectures that will be coming up probably in September or October will focus in specifically on direct hydrocarbon indicators. So I mentioned the term leads. A lead is a geological feature that looks very promising as it is considered as a possible future oil field or gas field. It should have a convergence of all the play elements. And so I talk about 5 play elements. In order for an area to work, we can't just have 4 out of 5 of the play elements, we need 5 out of 5. And so one of the things that would be considered is, do I have all 5 of those play elements within block 8, making lead A and lead B likely to be productive fields once we drill into them. We want to have an acceptable level of risk, and we want to see if it's likely that it's going to make some money for our company. We talk about an economic minimum, and so if I go up a slide, let's say we are interested in block 7, and lead C is the main thing that we're interested in for that block. That lead 7 would have an economic minimum, and by that I mean a quantity or a volume of oil or of gas that would lead to produce enough so that our company would get a 12% rate of return on our investors' dollars. So we would take the value of the produced oil or gas that we think lead 7 would yield. We would subtract from that all the costs, exploration, field development, field production, and the difference is therefore the profit. And so most companies have as a benchmark that they want to be able to make a 12% rate of return or more in order to be interested in an area and to develop a field. So for that lead 7, maybe we determine that we need 75, this is million barrels of oil, and that would be enough to give 12% rate of return. So if we found out that lead 7 had 200 million barrels, that would be fantastic. If we think it has 70 million barrels, that's below economic minimum, and so that would be risky. If it was 5 million barrels, then we wouldn't even worry about considering it any further. So we need to estimate the recovery. Let's say we're interested in lead B. We think it can hold 40 million barrels of oil. If we can lease the block and drill a well, we think that the recovery of the 40 million barrels that are in place, we'd only get 20% of that. And so in this example, it would be 8 million barrels. When we bring oil or gas up to the surface, it goes from high temperature, high pressure to lower temperature, lower pressure. And so the oil and the gas expand. The gas expands much more than oil, but it's not uncommon to have a 10 or 20 factor expansion. So if we think the oil would expand 10 times, the 8 million barrels now becomes at 80 million barrels at the surface. And this is an unrisked volume because we haven't considered the chance that all of the things are going to work. We may determine in our analysis that lead B has a 30% chance to have everything working and for there to be oil in that prospect. And so we take 30%, multiply it by the unrisked 80, and we come up with 24 million barrels as being the risked volume for that particular lead. So we think the risk volume is 24 million barrels. If we think in the future oil will sell for $55 per barrel, that's kind of a pessimistic view. Some companies might be thinking 80 to 100, and if you think of when lead B would be producing oil and gas, probably the earliest would be about 5 or 8 years into the future, and then it might have a 25-year field life cycle. So we're talking about 30 or 35 years into the future. But if we assume 55 and 24 million barrels, that's 1.3 billion. If we estimate the exploration, the development, and production cost is going to be 1 billion, that leaves us with a profit, potential profit, projected profit of $300 million. So with that estimate of 300 million in profit, that might be over a 25-year period. That would be something that would give a value to this particular lead. And then how does this compare to other leads, other opportunities that our company has to drill wells? If we want to capture Block 8 so that we can get access to Lead B and hopefully prove that it is an oil field, have other companies appreciated the value of this particular geological feature? How much might the other companies bid? And what we want to be is the high bidder without leaving too much money on the table. And so if we said we'll bid $3 million for this block, and somebody beats us out by bidding $3.1 million, that would not be very good. But if we bid $3 million for the block and the next highest bidder was $1.2 million, we would see a big gap between our bid and the next lower bid, and that's what we call money on the table. So I'm going to talk about the Gippsland Basin to give you an idea of the type of data and analysis that we do. And on the left is the continent of Australia, and down here the little orange is the island of Tasmania. The white box is where the Gippsland Basin occurs. So it is in the southeast corner of Australia within the province that's called the Bass Straits. And this is a production map for the Bass Straits in the Gippsland Basin. Red on the map are the gas fields and green are the oil fields. So of course, when we're looking at a new area that hasn't been explored, we don't know where those guys are. We've had about 50 years of exploration and development and production in the Gippsland Basin, so we have a good handle on where some of the main fields are. So I've already talked about the location in Southeast Australia. There is, and these are old quotes, so I think the numbers are probably at least 50% higher, 4 billion barrels of recoverable oil and 4.4 trillion cubic feet of recoverable gas. So let's look at the plate tectonic setting. Here is the Bass Straits, and the magenta oval is meant to represent the Gippsland Basin. About a third of the basin is onshore, 2/3 is offshore. We have exposures of some of the key intervals in mountains along the near the shoreline, and so we can get information from outcrops that can help us understand the subsurface. So we'll start back in the early Cretaceous. The depositional unit in the early Cretaceous was the Stratigraphy group. We have a triple junction here, one arm, the second arm, and the third arm. The western arm and the southwestern arm continue to have extension, and eventually we get seafloor spreading. The arm that goes through the Bass Straits and into the Gippsland Basin is the failed part of the triple junction, or an allocogen. The types of sediments that were deposited are early rift types of deposits. We'll talk a little bit more about the actual lithologies in the Stratigraphy group in a couple of minutes. We go to late Cretaceous time, and the Golden Beach is the formation that was deposited. It's middle Sin Rift sediments. There are some west-southwest, east-northeast faults associated with the allocogen, and it was in the late Cretaceous, Golden Beach time when we first had marine waters in this rift valley. Late Cretaceous to early Eocene, that's when we get the Latrobe group. This is the late phase of rifting. We have declining amount of sediment input compared to the rate of basin subsidence, and so we have a major transgression. The rifting ceases in Gippsland about 30 million years ago. The heat source, if you will, shuts down, and that leads to rapid subsidence, and we have a lot of extensional block faulting and a major marine transgression. Late Oligocene to recent, we have the lake entrance formation deposit. This is when the circumantarctic current started to develop. We have deep marine shales, and these deep marine shales form an excellent seal lithology. So in terms of the basin evolution, in the Jurassic, before we have rifting, we have normal thickness continental crust on the order of 35 kilometers. In the early Cretaceous, we have early rifting. We're starting to pull this apart, extension. We get a rift valley, and it's filled with sediment. We don't have a marine incursion as of yet. Towards the end of the rifting in the late Cretaceous, we do have a marine incursion. We continue to have more and more extension, more and more extensional block faulting. And then about 30 million years ago is when the area started to subside. We no longer had mantle convection, and so this area dropped very quickly and had a major marine transgression. So let me briefly talk about the stratigraphy. This is a stratigraphic chart. I mentioned the Strzelecki group, that's early rift. Then the Latrobe group that has as one of its formation members Golden Beach, that's mid to late rifting. We have a major unconformity that marks the end of the rifting when it becomes inactive, and we get rapid subsidence. And then we get the sea spray group on top of that. The basal member is the lake entrance formation, which is a deep water shale. So in the early Cretaceous, we have the Strzelecki group. It's mostly non-marine clastics, includes some coals, and we also get some volcanic layers within the Strzelecki. These coals become a secondary source interval, not the primary, but secondary. In late Cretaceous, we get the Golden Beach. This is mid part of the rifting. We have fluvial and lacustrine clastics transitioning into marine clastics. Here we get more coals, and these coals become the primary source interval for the hydrocarbons that are going to be generated. The upper Latrobe is the late phase of rifting. We have wave-dominated shorelines. We have more rapid subsidence than the sediment supply from the continent can keep pace with, and so we get a transgression or a backstepping of the shorelines. And the upper Latrobe is the primary reservoir interval. Then we have the cessation of active extension. The area founders quite rapidly, and we get the purple unit here, the lake entrance. That's a deep water marine shale, and that forms a world-class top seal for the Latrobe sands. On top of that, we get some limestones deposited in the Miocene, and that forms the overburden that's going to bury the source deep enough that we start to generate hydrocarbons. And then finally, we get the Pliopleistocene Tambo River. Again, that's not so much important in terms of exploration, other than the fact that it's additional overburden getting the source down deeper into the oil and gas windows. So we can summarize the hydrocarbon system here. The source rocks are coals, primarily in the Golden Beach and some in the Strzelecki unit. The main reservoir is the Latrobe group fluvial to nearshore sands, and the latest Latrobe is the primary reservoir. The trap is formed by extensional fault blocks associated with Cretaceous rifting. The seal is the lake entrance formation, the deep water shales that cap on top of the unconformity, the Latrobe Reservoir sands underneath the unconformity. And maturation and migration, we have had both oil and gas generated and migrated and in filling the traps. The major generation of expulsion started in the Miocene, and peak generation for oil occurs in the 4 to 5 kilometer depth range, and for gas, the 5 to 6 kilometer depth range. So one of the things that companies typically do in the early exploration stage is they'll show the stratigraphy, geological ages here, the geological column in terms of Jurassic, Cretaceous, Paleogene, Neogene, and then they have a column for the source, where the source rocks are, where the good reservoirs are, where the effective seals are located, what constitutes the overburden, when did traps form, and we can see here they were forming near the end of the Cretaceous, and then in the Oligocene, and then the timing of when hydrocarbon generation occurred. And so the Strzelecki coals started to generate in the Paleogene, and the primary source, the Golden Beach coals, started to generate in the Oligo-Miocene period of time. So a couple of references to some of the figures that I have on some of the slides, and that leads us to questions. And I'll leave this up in case we need to talk about some of the either past lectures or future lectures during the question time. So I will turn it back to our moderator, Dr. Bohan, and see if there are some questions that people in the audience have typed in the message box.
All right, thank you so much, Fred. That was very interesting. So I'll give you guys a few minutes to type your questions into the chat box. And Fred, I do have a question for you, if I can go ahead and start. At the beginning, you had said, you talked about 4 ventures that you had worked on yourself, and you
yes.
I was wondering which of those was the most challenging for you personally?
Probably the most challenging was the first one, because I was learning the ropes of how to do this type of stuff. And so I think it was a combination of getting up the learning curve plus understanding the Canadian Beaufort and understanding what sort of products do I need to generate so that I can communicate to management what the right decision about interest in the area and what areas to bid on. You know, they should be thinking seriously about. Each area seems to always have its own intricacies and unique characteristics, and 6 months sounds maybe like a reasonable amount of time. Some students that are listening in or viewing this in the repository maybe have worked a summer intern program for, say, 3 months. But it is a lot of information to try to collect and digest and analyze and then come up with recommendations.
So if you were giving advice to students, what do you wish you had known when you got started that you could tell people? What's that pearl of wisdom?
I think that understanding how your company operates, whatever phase you're working with, whether it's new ventures or drilling infill wells or somewhere in between, knowing the type of information your company is expecting of you, what sort of methods and tools and software, tricks of the trade you can use to get there. And I think the biggest thing people have to learn, and the quicker they learn it, the better, is what is essential work for me to do so that I can answer the business questions, as opposed to you know, chasing geological rabbits, things that are of interest. And certainly we would like to know all sorts of little details, but sometimes those details aren't really necessary, and we spend too much time chasing rabbits, and then we run short on the time that we have to do the proper analysis to answer the business question.
Right. That sounds very reasonable. Good advice. So we don't have any questions from the audience. I'll give you another second. If you could write questions you may have in the chat box.
Okay.
I guess.
And while we're waiting
for go
questions,
ahead.
On Thursday, I'll be talking about prospect mapping. And then next Tuesday, we'll have a topic on prospect risking. So that's kind of a good triple play here: new ventures, prospect mapping, prospect risking. Then we'll get a little bit more geophysical. We'll talk about well seismic ties, seismic acquisition, seismic processing, 3D seismic data, 3D seismic interpretation. And that'll take us through the end of August.
All right. I guess you did a perfect job of explaining it, because we don't have any questions in the question box. So I'll just remind everybody what you just said. We have another webinar on the 10th, same time, same place. Make sure that you register. And thank you again, Fred, for doing this web series. It really is, I think, a lot of excellent information. So appreciate your time.
Okay, well, I enjoy doing this, and hopefully it is beneficial to the students and professors that are either joining the live session or are viewing the recorded sessions. I appreciate IRIS for their efforts to make all of this possible.
Oh, wait, hold on. Hold on. I've got some questions that have come in. Hold on. Okay. Sorry, guys. Arthur says, thank you for the lecture. What is the most prospective area for new ventures now, do you think?
Oh, right now, that's a good question. I haven't, I've been out of, I've not been working for 3 years, so I'm not as current as I used to be. One of the things you can do is, if you look at some of the geological, geophysical magazines and journals, a lot of times companies that do seismic acquisition, they'll run ads and they'll show where they're collecting huge seismic data sets. And those are usually the areas that at least the contractors are thinking will be the next big area of focus. And so I know a couple of years ago, at least, offshore Greenland was a high focus area. The area around Madagascar was still pretty hot. And then there's a lot of speculation on where the next big unconventional resource play area will be. We have a number of areas that are active in the US, but there's a lot of areas in Europe or South America, Asia, where they're starting to think about using unconventional resources as a way to increase their production of gas and oil.
All right. All of a sudden, we've got a ton of questions. This is great. The next question, what competencies do you think that a geophysicist should learn in order to stay valuable in the oil and gas industry moving forward? That's from Fernando.
Okay. I'll talk about my Exxon view, because that's where I spent most of my career. The Exxon people, they like to see people that have a combination of breadth of experience and understanding and a depth of understanding in a particular focus area. So as an example, maybe you're a structural geologist and maybe on compressional regimes. They would be interested in that as a specialty, but they would also hope to have an understanding of stratigraphy, geophysics, maybe a little geochemistry, and so you have some breadth so that you're not so specialized that you don't know how the information you're using, let's say seismic data, how is it collected and processed, and then you don't have information, well, once I generate my structure maps, how is the next person going to pick that up and move something along so that eventually the company makes money?
All right, good answer. The next one is building on that. This is from John, and he says, what level of training do new hires get to be able to develop good plays?
The training that you get somewhat depends on the size and the philosophy of the company. I know ExxonMobil and Shell have very extensive in-house training programs. And I think every company I know of uses mentorships as a means to get young professionals up the learning curve rapidly. And so it's a combination of being assigned a mentor and then getting formal training either through in-house courses. Those could be classroom courses, in some cases field courses, or some of the mid-sized and smaller companies use companies that specialize in training people for the energy industry. Nautilus is one of those, and I mention that because I do some training for Nautilus. So again, it depends largely on the size of the company and how much they value the training. Training is something that you're investing in your employee for the future, and some companies are more short-sighted. I don't want to send Chris to a week of training because we need Chris to be doing X, Y, and Z. Whereas another company might say, yeah, we need that work done now, but it's more important that Chris has a thorough understanding of reflection seismology or geochemistry or wave equation migration or amplitude versus offset analyses.
That makes sense.
And I think if you're interviewing with a company and it's not the initial interview, but maybe they've called you back or maybe they invite you to your office, one of the questions I would ask in that situation is, well, what sort of training program do you have? And, how, kind of the way the question was phrased to me, how does a young professional get up that learning curve so that we can contribute more and more effectively to the company?
Right.
I'll also mention AAPG says that on average, it takes about 7 years for somebody coming into the industry to be a fully contributing member to the team they're on for the company they're working for. So every company understands that it takes 5 to 10 years for you to fully get up that learning curve if you ever get up the learning curve totally. I'm still learning stuff.
Aren't we all? All right, this question is from Dominic, and he asks, when governments announce blocks for bidding, do they provide data to interested companies to make all of the analysis of plays and leads before making an offer, or do the companies source data like mag and gravity from the literature to do their own analysis?
Usually the governments do not provide any data, and this is where the geophysical companies often have anticipated that a certain area is going to become available for bids. And so oftentimes they will shoot data and process the data a couple of months before a bidding round is announced. So they have people that keep their ear to the ground, listening for when might Angola have their next offshore sale? When will there be offshore sales for Greenland? When will there be opportunities to get real estate in, let's say, a government-held onshore area? And so usually data is available when the bidding, the blocks are announced. And it's just a matter of going out and purchasing that and getting up to speed on the local geology and geophysics and possibility for oil and gas. Again, the new ventures is done differently for the super large companies like Shell and ExxonMobil versus the smaller companies. Shell and ExxonMobil have new venture teams that work year-round on looking at where some of the new ventures might develop. Other companies, they only pull people off of other exploration projects to work on a venture area. So a good example of that is probably 4 years ago, we got word that Mexico was going to allow international companies to bid on, I think there's 4 or 5 different rounds. I think we've had 2 of the bidding rounds, or maybe 3. And so a company like ExxonMobil would have had people already studying Mexico. A smaller company like Noble, who I worked for up until about 3 years ago, they didn't have as much of their homework done. And so they would pull people, geophysicists, geologists, working different exploration areas together to form a Mexico team, and then they would obtain data and do the analysis so that they could participate in the bidding.
That's interesting. All right, thank you. So Mary wants to know if you have any experience in the West African basins.
Personally, I've worked a number of areas off of Nigeria and Angola. So those are the 2 West African countries that I have personally done work in.
All right, and our final question, I'm not going to be able to pronounce this name well, I'm so sorry. Oluwafunmike wants to know how we can gauge the percentage of taxes and returns to give the governments.
Usually when a licensing round is announced, the details about what the ground rules will be is part of the announcement. Let's pick on Greenland. When information, when blocks were announced to be open for bid, I believe Denmark would be the government involved. I'm sure that they made provided details on what percentage take the government would have and what sort of tax structure there would be for produced oil and produced gas. So it varies from country to country, organization to organization, but usually you know that at the get-go as to what sort of conditions go along with both the exploration and then the production of the oil and gas.
Right. All right, I think that is all of our questions. So thank you again, Fred. And we will talk to you again at 2 p.m. Eastern Standard Time on the 10th. Thank you for attending, everybody.
Great. And thanks for all the good questions.
Yeah, great questions. All right, bye-bye.
All right. Wish everyone